What is going on, everybody, and welcome to another Deep Learning with Python, TensorFlow, and Keras tutorial video. In this video and the coming videos, we're going to be talking about how to apply a recurrent neural network to a more realistic example of like what you're actually going to have to go through if you want to do make a recurrent neural network learn against some sequential data. So in this case, we're going to be working with a time series dataset, which is prices and volumes for cryptocurrencies. If you wanted, you could do it with, you could follow along and do the exact same thing with stocks. Or if you don't like finance at all, no matter what, like anytime I do a finance series, people are like, I don't get it. I'll try to be as simple as possible here. There might be some new terms, but it's pretty basic stuff. It's what's the price of the thing and how much of the thing is being traded at any given time. What we're going to try to do is take basically four major cryptocurrencies, and that is Bitcoin, Litecoin, Ethereum, and Bitcoin Cash, not necessarily in that order. But can we take those four cryptocurrencies and track their price over time, so like the sequence over time of their price and their volume, and can the recurrent net basically take sequences of all those prices and all those volumes? So in this case, like let's say we want to predict the price of Litecoin into the future. So can we take the last 60 minutes of Litecoin price and volume, Bitcoin price and volume, Ethereum price and volume, and Bitcoin Cash price and volume? So take the last 60 minutes of all of that data every minute. So this data is getting updated once every minute. So 60 sequences 60 long of all that data. And can we predict, say, 3 minutes into the future, what will the price of Litecoin rise or fall? Okay. So the same thing could be said. Maybe you're reading in sensor data to servers, and you're trying to predict whether a server is going to, overheat or something like that. Or maybe you're trying to predict traffic, like traffic to a website, and you've got like time of day and users or something like that. At the end of the day, what we're trying to do is either predict some sort of classification. In this case, is the price going to rise or fall? Or you could try to do like a regression. So you could have like that, the activation for the output layer could be a linear activation, and you could literally try to predict price or maybe a percentage change so it's all normalized. So anyways, something like this is really complex because you've got to do so many things to what's going to be a typical data set. So your typical data set is not, it's not even going to be in sequences. It's going to be one long sequence, and we have to build the sequences. And then just like everything else, we've got to balance the data. We've got to normalize the data, especially in this case, because the price of Litecoin is just different from the price of Bitcoin, as well as the volume that's going to be traded. So we really want this to be in relative terms, and then we also need to scale the data, and it won't be as simple as it was with image data where you just div by 255. So anyways, we've got a lot of stuff that we've got to think about here. Also with sequential data, doing out of sample is a little bit different challenge. So a lot of stuff for us to cover. Let's get into it. First of all, I've provided the dataset. I'll try to remember to put a link in the description, but otherwise go to the text-based version of the tutorial, which definitely will be in the description. And if you scroll down, there is a link to it. I could just copy the address, and let me just, we'll start a thing now. So we'll call this Crypto RNN tut.py. Yes. And let me just open that up in Sublime. So it's at this link, just in case I forget for whatever reason. That's where you can find it. Beautiful. So when you download that, I did all the shaping and then it wasn't where it needed to be. Anyway, once you've done that, let's see, pull this up. This is what you'll get. You'll get the zip, and then just go ahead and extract it. And then you'll get this crypto data dir, and inside of there, you've got these four files. Each one is basically just the price in US dollars of Bitcoin Cash, Bitcoin, Ethereum, Litecoin. So if we open up one of them, we can see here. So this is a Unix timestamp, and then I honestly forget. Let me check my notes real quick. It is the low, high, open, and close, and then volume. You do not need to understand what open, high, low, close is. Just understand that close is the price at the end of that 60-second interval. That's the price. So we're going to treat the close column as, hey, that's the actual price column that we're going to use, and then the last one there is volume. Okay, so what we want to do first is just check out the data and read it in, make sure we've got that working in the way that we intend. So I'm going to go ahead and import pandas as PD. We're going to be using pandas. If you don't have it, open up a terminal, command prompt, pip install pandas. Okay, so we're going to use pandas, and we're going to say df equals pd.read underscore CSV. And the CSV is in crypto underscore data. And then it is, we're going to go with LTC USD.CSV. And then, if you recall here, the columns aren't actually named here. I just spit them out from a database. So we're going to use names equals, and then we specify a list of names here, and that is time. And then it went low. It's probably going to go off screen, huh? Let's do this. Beautiful. Low, high, open. What's going on there? Why? Oh, we didn't close off low. Okay. Low, high, open, and then it was close. And then the last column is volume. So we'll read those in. And then let's go ahead and just print the head of this data frame. It's shift enter. Okay. All right, so we have the data read in. I have to fix this. This is over like by pixels. There we go. Okay, so now we've got the data read in, and we can kind of see what's going on. And again, we're really only going to concern ourselves with the close and the volume. But the other thing we need to be able to do is we have all this data in different CSVs, right? And what we want to do is get the close and the volume for each of them, and they all share the same index, which is time. They're all this data is organized by time, so we can join all these data frames on the shared, axis that is time. So the way I'm going to do that is the following. So we're just going to say MainDF equals PD dot DataFrame, and it's just an empty data frame for now. There has to be a better way to do this. I don't really know it. This is the method I always use for this, but there's probably a better way to merge data frames than what I'm about to do. But show must go on. Ratios. So this will be the files that we intend to use. So we're going to use BTC USD. We're going to use LTC USD for Litecoin. We're going to use Ethereum USD, and then we're going to use Bitcoin Cash, BCH USD. Then what we're going to do is for ratio in ratios, we want to iterate over these ratios. So we're going to say for ratio in ratios. I think we're just going to rename ratio here. So ratio will equal ratio. Let me think here. So I actually noticed an issue. So because what we really want to do is, I'll have to fix that in my notes. I have it wrong. Okay, so like if we just print ratio, I think what I had done initially was I used os.lister to iterate through the directory, and then later I decided to change that and just manually type it in. So I think that's what happened there. Anyway, we were about to do a silly split that didn't make any sense. Anyways, we're going to say the dataset equals, and I've started to use f-strings, so we're going to use f-strings. So that would be, actually it's crypto data slash, and then whatever that ratio is, .csv. Then we want to read in with the same names that we had before. So I'm going to copy dataset equals that. Oh, so what we need to do is, so that's our dataset. We're going to say df equals pd.read csv. We're going to read in the dataset, and then the names are the same names as before. And in fact, I'm just going to delete that one because we don't really need that one anymore. So we'll read in that data. We've got a data frame, and just for good measure, let me make sure we got what we expected here. Invalid syntax. Oh, we got two commas. What an amateur. Okay, so we've got the data frames. So this is like each singular data frame, and we want to merge them all. So there's a few things we have to do. First of all, we need to set time as the index. Like I said before, we're really only going to focus on the close price and volume. But if we try to join these data frames together, they share these names, like these names are identical. So what we want to do is give them unique identifying column names so that when we join them, we don't get a bunch of errors because we have like columns that are named identically. Plus, we want to know which column is which. So what we want to do now is go ahead and we don't need to print the head every time, I don't think. So we'll do df equals, and actually I think we can do it in place equals true here. df.rename columns equals, and then it's a dictionary to rename. So we want to rename the close column to be, and again we'll use f strings, and we'll do this ratio underscore close, and then we'll do the exact same thing with volume. So we'll say volume now becomes an f string. What do we want? Ratio volume. So ratio underscore volume. So we've renamed those columns. The next thing we want to do, oh, don't forget the in place equals true. In place equals true. And that's just so we don't have to redefine DataFrame, just in case anybody doesn't know what in place means. So then what we want to do is set the index. So df.set underscore index, and we're going to make that to be whatever the actual time column. And again, we want to in place equals true. And now we're going to specify that the data frame is actually just these two columns here. So we'll just copy, paste, and paste. Okay. So now this data frame is just the close and the volume. And what we can do now is, just to make sure, it's always a good idea just to continually print out, make sure you're doing things the way that you expect. I keep doing Shift Enter I wrote all like my notes in an IPython notebook, so I'm used to Shift Enter as running it rather than Control B. Okay. So as you can see, we've got all of the columns that we need, and now we want to merge them all together with each other. So the way that we're going to do that is with a simple question of if len MainDF equals 0, i.e. it's empty, MainDF becomes df. And then otherwise, else, what we want to do is MainDF equals MainDF.joinDF. Then we'll come down here, and then now let's print MainDF.head, run that one. Truncated all of our silly columns. So what we could say is for c in df.columns, it's actually MainDF.columns. Let's print c, just to make sure we got all the columns we're expecting. Sure do. Okay. Great. So now we've got that. The next thing that we need to start thinking about is, okay, so this is all just sequential data, right? So for any, supervised machine learning problem, we actually need two things. We need the sequences themselves, and then we also need targets. So we need to figure out, okay, how are we gonna go out making those targets? And then from there, okay, what are the targets? So we need to specify some starting constants. So we're going to say we're going to have something for the sequence length. We're going to need something for the future period predict. And then we need something for ratio to predict. So what are we going to try to predict? Like which one of these four things are we going to try? So for now, we'll go with Litecoin, so LTC USD. The future period, like how many periods forward, and a period here is 1 minute. So we're going to say 3 minutes. And we're going to use the last 60 minutes of pricing data to try to make that prediction. So if you were to, yourself look at a graph of the last 60 minutes of pricing and it's updated once a minute, logically you could probably do pretty good predicting out the next 3 minutes, but maybe not. It's probably still a 50-50 actually if most people sat down, but we could believe that that begins to sound reasonable. Especially if it's not just the last 60 minutes of the single asset that's Litecoin, it's the last 60 minutes of Bitcoin, Litecoin, Ethereum, and Bitcoin Cash, and the volume and all that. So probably a machine could at least do a little better than a human. How much better? We'll see. So once we have that, we need to create the actual targets and basically a rule for the targets. So we're going to define classify. And this would be basically our classification. So what we're going to do is take the current price and then the future price, whatever those happen to be. And then the question is pretty simple. If float current is greater than float future, so if the current price is, and I don't really like the way I've worded this. Let me do, if float future is greater than float current. So if the price is higher in the future than it is right now in our training data, then we're going to say those features were a 1. Else we'll return 0. And we'll say 1 is a good thing. 1 means you should buy this. So we want to train the network that, based on this sequence of features, in general, with this sequence of features, price goes up here. And with this sequence of feature, price goes down here, and so on. So we're hoping that the model can learn that relationship. So now we'll come down here to this MainDF, and what we can say is main_df future, because we need to get the future price, equals MainDF, and then what we want to do is another f string, and we're looking for the ratio to predict underscore close, right? The future price is going to be based on that close column. And then what we want to do is shift that close column, basically like up however many future predict, how many periods forward we want to predict. So that's going to be a negative future period predict. And then let's print that. Unfortunately, I think it's only going to show us like 2 columns, which is really annoying. What did we screw up here? Oh, okay. Yeah. Fix the curly brace there. That's the variable. Okay, try again. So that's the future price of Litecoin. Unfortunately, we're not showing Litecoin. So I'm curious if I can get away with the following. So we want to show future, and we want to show this price right here, or this column at least right here. We just want to make sure, again, this stuff, oh shoot, what have I done? There we go. Especially when you're working with data like this. So this should be the price in 3 periods. So here, and then 3/8, this is the price. So currently the price is this, but 3 periods in the future, it's going to be this. And sure enough, there it is there. And then the same thing here. Here's the current price. In the future, though, it's going to be this price. And we can see that is the case here. Again, you just have to always be checking every step of the way. It's so easy to make a mistake. I'll be really surprised if after I'm completely done with this tutorial and post it up, that there isn't a mistake in this code, because it's just so easy to make mistakes on doing stuff like this. Anyway, it looks right so far. So now we've got the future price. Now what we want to do is map this function to a new column that we're going to call target. So we're going to say MainDF target equals list. This just converts the output to a list that we're just going to assign as a column. So list, and then we're going to map something. What are we going to map? We're going to map that classify function. And then after the function is just each of the parameters. So in this case, it's the current column and the future column. So the current column is MainDF, this right here. So it should be MainDF, boom. So the close column, and then we want the future column. So MainDF future. And then I'm going to cut this here, paste, and let's see if we can get away with target. And then again, we're just trying to see, does it work as we expected? So here, we can see here's the current price, here's the price in 3 periods in the future. That's less than the current price, therefore the target is 0. Good. Let's see if we can't print a little more. So let's do 10 values for the head here. Okay, so this is the only one that's a buy. So here's the current price, but 3 periods in the future, it's this 47. So yeah, 96.47, which is true. So based on the features here, hey, we want it to know that's a 1. Okay, so at this point, looks great. We're ready to make some sequences and train the model. Well, settle down there, Carl. We have a lot more to do. So we still have to build the sequences. We still have to balance the data. We still also have to normalize the data because the prices and volumes of Litecoin are very different from Bitcoin. And then we also still have to scale the data. And probably a bunch of other things that I'm forgetting right now, like out of sample. So we have a lot of work ahead of us. So I'm going to stop it here and carry on in the next tutorial with the next steps that we have to do. So if you've got questions, comments, concerns, if I've got an error in the code you think up to this point, feel free to leave those below. Also, a quick shout out to the most recent sponsors, Boom Billy, Harsh, Soth, Mark Zuckerberg, JT, and Newcastle Geek. I keep seeing Newcastle Geek. I don't know if the memberships on YouTube are updated each time if you stay a member or not, because I feel like the only person I keep seeing over and over is Newcastle Geek, and maybe everyone's like becoming members and then not. I don't really know. But I keep seeing that name. So anyways, that's it for now. And thanks again for you guys becoming members. I appreciate the support. And I will see everybody else in the next video.